Aha. Okay. So today we're talking about ANOVAs. Yay! Super exciting. So what ANOVA stands for is analysis of variance. This basically means that you have a continuous dependent variable and a nominal or ordinally measured independent variable. But that nominally or ordinally measured independent variable has 3 or more categories. So that's the only thing that makes it different from an independent t-test. An independent t-test, the IV will have only 2 categories. And ANOVA will have 3 categories. So that's how you tell the difference between if you're going to run an independent t-test and an ANOVA. So here are our course objectives for today. I know they're very long and exciting, so I'm not going to read them to you, but this is what we're going to learn today, I hope. So some characteristics, it's super similar to that independent t-test, like I said. The DV is always continuous, always. So if your DV isn't continuous, it can't be an ANOVA. And the IV is always categorical, which means nominal or ordinal, with at least 3 independent categories. So we wouldn't run a one-way ANOVA if there were 3 assessment time points, because they are not independent groups. That would be measuring this class at 3 different time points throughout the semester. You are the same people getting measured at 3 times. That's not a one-way ANOVA. It's a different type, but we're not going to learn how to run that in SPSS, so don't worry about it too much. The only one you have to run in SPSS is this one-way ANOVA. The goal is to detect a difference between group means. So when you have those groups of your independent variable, maybe you have 3 different diseases you're looking at, and you're looking at your dependent variable being stress level, and maybe you have cancer, diabetes, and what's another disease? Hypertension, maybe. Those are your 3 diseases that you're looking to see if stress levels differ in those 3 groups of people. So we want to see if there's a difference in cholesterol mean between those 3 groups. That would be when we're looking at a one-way ANOVA. Oh, here's another one. A research question. Is there a statistical difference in the post-program mean BMI between younger, middle-aged, and older adults who took part in the same exercise program? So our dependent variable here is post-BMI. So after the program, they got their BMI measured. Then the IV is your age group. So that's measured ordinally because they're ranked in order: young, middle, and older adults. And this picture just illustrates that you can't be in each of these groups at the same time. So maybe younger adults is 18 to 34, middle age is 35 to 64, and older is 65 to 80. So no one person can be in all 3 groups, any of the 3 groups, besides one at a time. Okay. So a way that we can enter this into SPSS, using that same example, we're going to put in their post BMI with each row being 1 person, and we have the DV in one column and the IV age in the other column. So I put the ID in just because it makes it easier for me, but if you don't like it, that's fine. So then, say for example, these are BMI levels, and we have those 3 age groups. So we label the younger group as 1, the middle group as 2, and the older adults as 3. So for the person number 4, which age group would they be in?
Middle.
Yep, middle-aged, because they're labeled as 2 over here. Now remember in SPSS you can press that A arrowy thing 1, and that will change it from that number to the word if you put the words in your value labels. So if you like that better, go for it. What is the BMI of the last person in the older adult group? 24.9, yay. So that's just kind of looking at what the data is showing you and how you can put it in. So if we had a list of BMI and we had them separated into 3 columns by group, so the youngest group was in our first column with all their scores, then the middle age group was in another column with their BMI scores, and then the oldest group was in a third column with their BMI scores. This is how you would put it into SPSS. Hint, you're going to have to do that for your homework. So if there's 3 columns and you're doing a one-way ANOVA, this is how you put it into SPSS. Okay. It's very similar to the way you put in the data for the independent t-test. There's just a third group. So how would we enter this data into SPSS? So we're going to track weight gain in rats fed 4 different brands of cereal. So I picked the good ones, like Cheerios, Fruit Loops, Cinnamon Toast Crunch, and Rice Krispies. If we're going to put this into SPSS, how would we do that? What would the first thing we do it be? Open SPSS. Okay. So then we're going to make 2 labels. If you want to do this on your computers, you're welcome to. Then we're going to make 2 variables. One would be weight gain. That would be our dependent variable because weight gain is measured continuously. And then our IV would be cereal, and you would go into the value labels and label 1 as Cheerios, 2 as Fruit Loops, 3 as Cinnamon Toast Crunch, and 4 as Rice Krispies. Or you could just leave them as 1, 2, 3, 4 if you don't like those cereals. Whatever, it's fine. So those are your first steps. Then what would we do? So we have our variables made. What are we going to do next to get this data from this kind of a table into that? So the way I would do it is to go down this first column and put, for the weight gain variable, 5 ones down the column. And then in the column for cereal, I would put 1 because that's what Cheerios is. They're in the Cheerios group. So in that, they would have a list of 5 ones. So then you would have 5 rats in your SPSS data file. So then next, I would put the 5 sevens after, underneath those 1s you put in the dependent variable of weight gain. And then I would put 2s next to them because they're in the independent variable cereal column because they're in the Fruit Loop group. And so on for Cinnamon Toast Crunch and Rice Krispies. So then when you do that, dun dun dun, it looks like this. If you can see that. Oh yeah, it's pretty big over there. So this ID column just says that we have a total of 20 rats in our study. And then this is how much weight gain there is and the cereal type that they were assigned to. Cool. Oh, so that's just how you enter it. I think I come back to this and we go through the rest of it, but I just want to show you a little bit about what SPSS does behind the scenes for a one-way ANOVA before I show you what the results are for it. Don't get scared. So this is the formulas that SPSS is using when you click the one-way ANOVA button to get your results. You don't need to memorize these because we're not super statistician humans. This confuses me. What doesn't confuse me is this last bottom part here as much. So here it's showing you the people that were in the condition, what their I can't remember what this is. Something that I should remember. Anyway, the F statistic is the distribution the sampling distribution, which was used for testing. So this is what you report for part of your test statistics. You're also going to have your degrees of freedom reported. So you'll report both those in the condition and the error numbers. And then we have this and this are something, but they aren't super important, so don't worry about them. This is from your book, which goes into way, way, way more detail than you ever want to know. So if you didn't read it yet, don't, because you'll just be lost. It's totally fine. What is talking about between group and within group? The between group is the variation between the groups means, so like the different serials. What is the variation between those different categories? And within group is looking at the variation within each serial group. So within the Cheerios group, there was no variation because everyone gained 1 ounce. In the Cinnamon Toast Crunch group, there was a lot of variance because not everyone gained the same amount of weight. So that's what this is talking about. Now we're going to keep going. So some characteristics of the F distribution. So what we've been doing up till now has been the t-test for the independent and paired t-test and the chi-square value for the chi-square test. So the F distribution is what we're finding in the one-way ANOVA test. So it's very similar to the T, and you're writing your output, or your summary of what you found in SPSS will be similar. F is found from the between group variance divided by the within group variance. So that last slide tells you how they calculate that. Too many numbers, too confusing. That's enough. But it is positively skewed, and the modality is 1, about 1. So this is kind of what the F distribution looks like if you ever need to know for some reason. Some assumptions. These are more important. So when we run a one-way ANOVA, we're assuming that the observations are independent. That means one rat can't be in more than one of those cereal groups. They were only getting fed one of those cereals. They weren't getting fed Cheerios and Rice Krispies, just one. So they're independent. The data in each group are normally distributed. For this class, we're just going to assume most of these because it makes it a lot easier. But out in the real world, you need to actually test these things to make sure they exist before you can run the test. So data in each group are normally distributed. So remember, that's that normal curve we were talking about before. And this would be assessed by either looking at a picture of the histogram or a skewness value, which you can find in the SPSS output. Then homogeneity of variances is the variance of each group, assuming that is equal. So there is a way to look at this. We're not going to worry too much about it because otherwise we would have to run another test and that's too confusing. So just assume that everything's good. The only time that you would need to be worried is if there is less than 20 individuals in each group, because then all of these things are not real, and then you have to run some other tests that we're not going to learn about yet. So if there's less than 20 in each group, but there's not in your homework, so don't worry for now. The hypothesis testing steps. So you think about your hypothesis. So the null hypothesis, or H sub 0, is that one group is equal to the second group mean is equal to the third group mean, and so on for however many groups of your independent variable there are. And then the alternative hypothesis, or H sub 1 or H sub A, however you write it, would be that at least one pair of group means is different from each other. So this means that there's at least one group that's different in our cereal, in their weight gain, than the other 3. So maybe it's that Rice Krispies were significantly less, there was significant less weight loss than weight gain than the Cinnamon Toast Crunch group. But all the other groups were like sort of similar. That's what we're saying with that alternative hypothesis. Does that make sense? Kind of. Okay. So we're going to set our alpha. This class is 0.05. You don't really have to do this because SPSS does it for you. Our test statistic is the F, and this is just the formula for the between subjects and within subjects thing, but we're not going to actually do this. This is just going to come out in SPSS, and you're going to be like, look, it says F, and this is the number I'm going to put in my write-up. Yay! And then the p-value and your conclusion based on that p-value. So here's where we're going to finish going through this example with the rats and the weight gain. So this is just what the data looks like. So we put it into SPSS and we run the ANOVA. So here's what we first come up with. We're going to look at this table that comes up. This is the first table. So we get the between groups and within groups. This is the sum of squares. Now I remember what those are. SS is sum of squares. Sorry, guys. So that's just telling you what that value is. We don't really use that in here, so you don't have to worry about it. Degrees of freedom, that's important. You need both these top two numbers in your write-up for your results. The mean of squares, we're not going to worry too much about that either, but it's there for you if you need it for some reason. Then this is our F value and our significance. So since this is less than 0.05, is it significant or not? It is significant, which means that there's at least one group that is statistically different than the other groups. But we don't know where the difference is based on this one table. So we have to run these post-test analyses, which are called post hoc testing. But it really does it at the same time as your first one, if you do it right. So, what these are, oh, Stacy's here, yay! So we'll talk about more of this in a minute, but you're going to do these fun and exciting surveys.